Okay, geometric series. So a series, be it arithmetic or geometric, is the sum of the terms. So a geometric series is formed by adding the terms of a geometric sequence. Basically replacing commas with plus signs, right? So you're adding it up. So if we have this series, so here's the sequence, 2, 8, 32, 128. We recognize that it's geometric and has a common ratio of 2. 4, right? So it's a geometric sequence, has a common ratio of 4. This is the geometric series which results. To determine the sum of these 6 terms. Wait, no, things are down. Okay, wait, we're going to do this. So to determine the sum of these 6 terms, S6, we do the following, right? Here's what we do. We take 4 times S6. I think it's backwards. It's like she saved it. So, hang on, don't look. There. It's like Miss Tongue says, "Hey, I'm going to show you something really neat. You know, this is stuff," and then it's like, "Yeah, that's all saved now that way." So I can't show them the neat stuff. So, oh, hey, I got into it. Wow, it's like it's impossible. Okay, so if we want to get S6, we're going to add up 6 terms, right? Which is 2 plus 8 plus 32 plus 128 plus 512 plus 2048. Now here's the trick we're going to do, right? I don't think Gauss thought of this one. I'm not sure.
He's pretty smart. I'm not sure.
We know the common ratio is 4, right? So what happens if we multiply everything by 4? Well, we end up with the same terms, right?
Yeah.
Except for the first term here and the last term there. Those are, but the other terms are the same. So what we can do is we can subtract. Right? So I line it up. So this minus this. So we get 4S6 times S6. Or sorry, 4 times S6 minus X6. So how many S6s will there be? There'll be 3 of them, right? We got 0 minus 2, which is?
-2.
-2. You think of a 0 being there, right? These guys just, and we've got 8192 minus 0, which is?
8.2.
So we subtract, we end up with 3S6 is equal to -2 plus 8192. And we work that out. So 3S6 is 8190. And S6 is 8190 over 3, or 2730. This is all on your sheet, right? Yeah. So don't look at your sheet, just look up here.
Okay.
Your sheet doesn't have the Zudi stuff. Yeah, I know. I was going to, but went in the right basket. What are you talking about?
No,
Oh, apparently that's all there is to be revealed on this one.
there's no more.
Similarly, we have, wait, where's the, oh, wait, go away, back.
We can see every day.
I know.
I can see that.
All right, never mind, so you can't see anything. Okay, so.
The video records all the evidence.
Yeah, that's right. It's all there. Oh, and in black too. I don't even get my purple line. I don't know why. There should be preferences that are saved. That's the way it used to work. Okay, anyways, so instead of taking 4, which was the common ratio, we're going to take R. And instead of S6, we're going to take S sub n. So if we multiply S sub n, which is T1 plus T1 times R, etc. If we multiply that by R, well, here's S sub n, right? T1 plus T1R plus T1R squared, all the way down to T sub n, which is T1 times R to the n minus 1. Right? That's our formula. Okay? And if we take R times S sub n, then we're basically just offsetting, right? And we end up with R minus 1 S sub n. So remember, we had a 4 here and a 1 here. That gave us 3 of these. We had 0 minus 2, but we just have negative T1 plus T1 times R to the n, this guy here. Okay? And we do a little manipulation. So R minus 1 times that is T1 R to the n. All we're doing is flipping them around, right? So instead of doing negative 2 plus 8192, we do 8192 minus 2, which didn't matter with numbers, but you know, when you're doing this, it's better to have it in this form. Well, that's R minus 1 times S sub n, so we can factor out a T1. right? T1 gives you r to the n minus 1. And we can divide both sides by r minus 1. And here is the formula for the sum of a series, right? Well, here is a formula, not the formula, because the formula would imply there was but one. This is a formula for the sum of a series. But, is there another one? There's something here, no? But here, we shall reveal. Ah, yes. Oh, wait. I'm not supposed to do that one first. Oh, never mind. Okay, look over here.
The world has ended.
Yeah, I know. But t sub n is t1 times r to the n minus 1. If I multiply both sides by r, right, I get rtn is t1 r to the n minus 1 times r. Okay, that's just this, and then, you know, flick those around. Rtn, why are we interested in Rtn? Well, because it's down here, right? We'll get R. Sorry, we have, what do we have? We have something over here we want to replace it, right?
Something over there.
So Rtn is this. Rtn is T1 times R to the n. Going back to here, right? T1 R to the n. Well, T1 R to the n, right? That's the same thing. So we can replace it with R times T sub n. And so here is another formula.
Oh my.
Right? I don't believe you're responsible for their derivation of the formulas, just for their use. Okay? You need to be able to use the formulas. So there's two formulas. What do they have in common? What's the same in both of them?
R, T1.
They both have R. They both have an R minus 1, but really that's just knowing R. We don't need to know yeah, okay. So we need to know R. What else? They got R. They got S sub n. What else?
T1.
T1.
So what do we have to go?
Okay, so what's optional then? Well, what does this one have that this one doesn't have?
A factor form.
Okay, it's got an n. Right? There's no n in this formula. There's a t sub n, there's no n. We don't need to know how many terms. To use this formula, what are we looking at? First term, last term, common ratio. Right? It's like the arithmetic one, right? We've got a formula that uses first term, last term, common difference. Well, with geometric, we got a formula that uses first term, last term, common ratio. With arithmetic, we've got a formula that uses first term, number of terms, common difference. Here, we've got a formula that uses first term, number of terms, common ratio. Right? You can draw any parallels you would like. Those are the parallels that I have drawn. Okay, so let's solve some problems. So there are two forms. Now you can open up your books, right? Because you'll need to. Because we're going to do a pile of examples together. Right? That's all we ever do in math. We never have you discover stuff. Well, that's not true. We have the occasional worksheets where you discover stuff, but this is the direct instruction, which apparently you prefer in person. Go figure. Video generation. Ha!
Lies.
Yeah, I know. You guys are more conservative than Southern Baptist Republicans or something. I don't know.
That's not that hard.
Okay, example 1. Determine the sum of the first 12 terms of the geometric series. Okay, I'm going to pause because I want to bring up my tools. Okay, so two formulas. Each formula involves 4 quantities. We have a total of 5 quantities altogether, right? One of the formulas uses n, and the other formula uses t sub n. So we need to figure out what we have. Do we have t sub n? Okay, well, let's just start. What do we got? What's t1?
5.
t1 equals 5. What is r? Negative 2. We need r, right? Both formulas need t1. They both need r. If you don't have them, you got to figure them out somehow. Okay, n. What's n? N is 12. So what are we trying to find? S sub n. We don't need t sub n. We don't have t sub n, but it's okay, right? We're good. So let's write out the formula we're going to use, right? It's up at the top of the page here. You're going to get a formula sheet. In IB, you get a formula booklet. It's like,
Yay!
you know, but you also have to do one test without calculators.
Yay! It's going to be the easiest test.
Okay, so S sub n is t1 times r to the n minus 1 over r minus 1. Let's fill it in. Get your calculators out, right? Because you need to practice doing these, making sure you're putting it into the calculator properly, getting the right answer, right? So S12 is 5. Negative 2 to the 12 minus 1 over negative 2 minus 1. So negative 2 to the 12th, which will be a positive number, was 4,096. Minus 1 is 4,095. Times 5 is 20,000 and change. 20,004. So divided by negative 3, which is, so what do we get? What's the answer?
Negative 6825.
6825. Okay, I'm just going to trust whoever first calls out an answer. I don't have my answer sheet, like it's somewhere, but so whoever first calls out an answer, you need to be working this out to either say, yeah, I got that answer as well, or no, I got a different number, and therefore maybe we want to look at this in a little more detail. So you either concur or you do not concur. You concur? Okay, everybody's cool? Right, moving on. Okay, so this is set up so the formula will always be there, right? So, oh, method 1, method 2. Okay, example 2. Determine the sum of the geometric series 1458 plus 46 plus 162 plus that plus 2 9 by 2 methods. Well, 2 methods kind of implies we're going to use both formulas, right? So, what's method 1?
Let's write them all out and add them.
Which one do we want to use? Which of these formulas?
Still method.
Okay, so what do we know? Let's list up here. What do we know? What's T1? Okay, what's R? Okay, so it's called 1/3, right? I always like to multiply by, don't think of dividing, think of adding, and maybe you're adding a negative number, or think of multiplying by the reciprocal, right? So R is 1/3. Okay, what else? What's N? Don't know. What's T sub N?
2 over 9.
What's S sub N? Well, that's kind of the whole purpose of why we're here, right, is to find S sub N, so obviously that's unknown. So what method would you first choose?
The second one.
Okay, so we use the second formula because we have everything that we need for it, right? We have T1, we have R, we have T sub N, okay? So we don't need to know N. So S sub N is R Tn minus T1 over R minus 1. Okay, so R, 1/3. T sub N, 2 9 minus T1, 1458 over 1/3 minus 1. Okay, do we need any details or we just need an answer?
Just an answer.
All right, give me an answer.
A number.
Remember, Grant, it's not the math we were going to work on in this class. So, give me an answer. What do you got? I don't know. I misplaced my answer key. I have no idea where it is. Well, work faster. Why are you all so slow? Why does nobody sit up front?
I used to until you yelled at me.
Doesn't matter where you are. I'll still yell at you.
I've got this.
Got a number yet?
8, 6, 4, 8, repeating.
Give me a fraction. Go math, enter, enter. What's it equal to?
What?
Go math, enter, enter.
Well, it is 19682 over 9. 19682 over 9.
Okay, anybody else get that? Same, different? Yeah? What? Same or different?
Yeah, it's
It's the same? You have to ask him to give you a fraction.
I do have a separate book. Well, it's
That
not
will take forever.
His answer is calculator.
Okay, what is method 2? What is method 2? Do they find n and then? Okay.
It's like 200.
What is it?
Yeah. 1/3 gets canceled. Yeah. Right.
What was method 1 then?
Why would
It's where you use n.
You find n
Yeah.
or determine n?
Where you use your calculator and you substitute 9 as n.
Okay, so we got to find n.
Yeah.
Okay, so in method 2, we need to determine n, right? Which means we're going to be starting with t sub n is t1 times r to the n minus 1. We know t sub n, which is 2 over 9. We know t1, which is 1458. We know r is 1/3. And we know that this is n minus 1. So, what are we going to do? You could graph it. Yeah, you could graph it just the way it is. All right, find n graphically. Give me n.
Ooh, give me a calculator.
Or just use the table, right? Like, you don't even need to graph this really. You could just use the table on the calculator. That's probably easier. Right? So just punch this in. 1458 times 1/3. Well, first of all, what's 2/9 as a fraction?
0.2.
Yeah, 0.2 repeating.
Yeah.
Okay. So if you know that, then just go 1458 times 1/3 to the n minus 1 as y1. Go second function graph into the table and scroll down until you find 0.2222. Because they won't be fractions in your table.
Because they are all liars.
Okay, so what's n?
What do you take this to?
9.
This. y1 equals 1458 times 1/3 to the n minus 1. X minus 1, really.
9.
9, thank you. N is 9. Okay, and now we can use the other formula, which is T1. So S sub n is equal to T1 times r to the n minus 1 over r minus 1. And we'll scroll down. We'll move the shade a little bit. So S sub S9 in this case, really, right? We're finding the sum of 9 terms. Is T1, which is 1458, times 1/3 to the power of 9 minus 1 over 1/3 minus 1. Which is, so do this. Put that into your calculator. You got to be able to get this right. Else you'll be wrong. If you don't get it right, you get it wrong.
5962 over 9.
How did you get that?
I don't know. I'm a calculator. I don't understand how it works.
Okay? But you want to get that, right? You need to be able to punch this in your calculator and then go math, enter to change it into a fraction, right? Because it's really what? What's the actual number? It's like 2,000 and something, or?
It's something 0.8 repeated.
Yeah, so it's 2, starts with a 2, 2, 1, 9, 2, I don't know, 219 something 0.8 repeating. Okay, and then you go math, enter, change it into a fraction. I'm just going to pause this because, otherwise. Why can't you have a negative? You actually have to have a negative somewhere. Well, if the sum is negative, and if the ratio is positive, then the first term has to be negative, right? Because if the first term were positive and the ratio were positive, all we'd have is a whole pile of positive numbers. So it's not 3, it's -3.
I lied.
Okay? Questions? Concerns? Next. Pay attention. It's like deep pulse. Every hand over, oh my god, one of those. Okay? A Super Ball, named after the Super Bowl. True story.
Really?
Seriously, when they developed, you all know what a Super Bowl is?
Yes.
Super ball is like a very hard, dense rubber ball which bounces fairly high. You know, most balls, you drop a ball and it sort of bounces up a little bit, right? I drop a tennis ball, it's going to bounce up like about that high, right? But a super ball will bounce to 70% of its previous height, or more. It could be 90%, right? Which means it's retaining a whole pile of the energy as it compresses and then is released, right? There's, you know, kinetic energy, there's potential energy here, and you drop it and it hits the ground, changes into kinetic energy, right? And moves back up. And the thing is, how big, right? And then they did one about the size of a bowling ball and it hit a car and sort of bad news for the car. But anyways, yeah, it was around the time of the Super Bowl that they had developed the Super Ball, and so that's why the Super Bowl. No, actually, that's why the Super Bowl became the Super Bowl.
What?
The Super Bowl was named after the Super Bowl. Sorry, not the other way around.
They use that word super.
The football, yeah, it was just like the football finals, right? But then the Super Bowl came out around the same time, and you know, I can find a Wikipedia article that'll show you that. So.
But Wikipedia lies.
Anyways, so a super ball is just a ball that bounces up. It's dropped from a height of 10 meters. It bounces to 70% of its previous height. Determine the total distance. So imagine the ball has a little odometer in it, right? So you drop and it goes, I traveled 10 meters, and it hits. And then I come up, how far? 7 meters. So I've traveled total of? 17 meters. I go down and I hit the ground. I've now traveled total of?
17. Oh, total.
Total of?
17.
No? Drop it. 10. Hits 10, right? Up 7, travel a total of 17. How far down? 7 for a total of 24. How far up?
A number.
70%.
4.9. You can't multiply 7 times 7, and then down 4.9, right? Okay, so we got the idea, right? Determine the total distance the ball traveled when it hits the floor for the 4th time. Draw a diagram. I swear to you, draw a diagram. You have to draw diagrams for this. Okay? Well, okay, you don't have to. I have to. No way I get this right without a diagram. It just doesn't happen. Okay, when it hits, because I need to know a few things, right? Like when it hits for the 4th time. So this is 10 meters, right? 10 meters. Da-da, da-da, and we drop the ball. And it hits for what time? How many hits?
1.
That's hit number 1. And then it comes up 7 meters, and then it hits for number 2. And then it comes up some distance, and it hits number
3.
and then it comes up some distance, and it hits number
4.
and that's what we want to figure out, right? Is this plus this plus this plus this plus this plus this plus this, which if you're watching the video is going to make absolutely no sense because you know nothing actually happened there. But it's the sum up. Now we have a problem, or not a problem. We have an opportunity, which is, well, we know that this distance here is doubled, right? Because it has to come up that and down that, and this distance is doubled, and this distance is doubled, but this distance isn't doubled.
Let's through it up.
So now we have a choice to make, right? Which is either we can sum up this 7 plus the 4.9 plus the 3.43, which is the other 7 times 4.9, which you can't possibly do in your head. And we could add those up, right? And then double them because it goes double the distance. And then at the end, add on the original 10 meters, right? Or we can start with the 10 and then add the 7 and then the 4.9 and the 3.43 and double that. But then we would have to do what?
Minus 7.
We'd have to subtract 10. You subtract 7, it's fine. But
Why does this start at a straight line? Beginning?
that's not a straight line. That's the top of the building from which it is dropped.
Oh, okay.
That's a sharp building.
Building.
Biology.
Okay. So it's dropped off the building, right? The roof. And it travels 10 meters down. So, what would we like to do? What do? Do you do the 10 twice and then subtract 10, or you do the other side and then add? Subtract the 10? Okay. So, if we do that, right, so we have 10, 7, 4.9, and so on. Right? It's going to keep going. I actually know what it is, but we'll pretend we don't.
3.43.
I know it's 3.43. Okay, so this will be T1, T2, T3. Okay? So what we want to add up is we need T1, T2, T3, and T4. Right? That's what we have to add up. And then what we're going to do is we're going to double that. And then what we're going to do is we're going to subtract 10. Right? Because we will have, when we double it, we'll have doubled. You know, this is good. We want to double this, but not that. Okay, now this example is relatively trivial since we know that's 3.43 and we could just go 10 plus 7 plus 4.9 plus 3.43 times 2 minus 10, enter, right? But we're going to use the formula because we're going to ask questions like when it hits the ground for the 8th time. All right, now part of that reason is, right, so this is first, second, third, fourth. Okay, because what I want to do is be able to label that diagram. So when it says, when it hits the ground for the 87th time, I don't have to sit there and draw out 87 of them, right? But I can generalize it back to, okay, if I wanted 4, then I'm looking at adding up T1 through T4, right? I'm looking at the sum of 4. So we're looking at doing this, right? We're looking at doing 2s4 minus 10. Okay? Everybody understand why we're doing 2s4 minus 10?
Yes.
Okay? So when it hits the ground for the 4th time, we will have 4 terms of the sequence, right? We have the 10 term. We have T2, which is 70% of that, right? So T1 is the 10, T2 is 70% of that, T3 is 70% of that, T4 is 70% of that. It'll hit the floor for the 4th time. We want that distance, right? We want it doubled, but we want to subtract 10 because it never bounced up 10 in the first place, right? It just fell 10. Okay, so let's do this. So what do we know? Oh, what else do we know? R is 0.7, n is 4, t sub n is, we're going to say we don't know just because at some point it's like 8 times and we don't actually know it. We can't just kind of do it in our head or work it out fairly easily, right? So you want to generalize this to like 8 bounces or 10 or 12 bounces or something like that, right? Just to give you an idea. Okay, what formula are we using? First one, which is what? Is this right? It's not, is it?
It's t to the power of 1 times r power n minus 1.
T to the power of 1 is just T.
T to the power of 1.
No, not the power of 1. Oh,
So it's T1
so what?
times what? All right, so the lesson there is don't memorize formulas. Take them off the formula sheet. Okay, if you memorize them, you'll get them wrong. You'll get the quadratic formula wrong, you'll get the thing, you'll leave something off, you won't square something you should have squared, you'll remember the wrong formula, whatever. You will have a formula sheet, you will have formulas at the top of the test, you will, ultimately when you're writing the IB exams, you will have a formula booklet. When you're doing the diploma exam, you will have a formula sheet, which is actually a tear out. The formula booklet is fine because it's a separate booklet, right? So you just get to keep it off to the side. For the diploma exam, it's a tear out sheet. Tear it out. Keep it on the desk handy where you can see it. Refer to it often, like anytime you use a formula. Okay? Because otherwise you'll start getting formulas wrong. And then great, you know all the math, but you don't get any marks for it.
Lol.
All right, so S sub n, what's T1? It's 10. 0.7 to the what? 4 minus 1 over 0.7 minus 1. Okay, so that's S4. What is S4? And then just leave the number in your calculator. 25 point what? 3 threes?
Yeah.
Like just 3, 3, 3?
2 3. Like
What?
3 3. Like 3 and there's 2 threes. There's 2 threes.
Like this?
Yeah.
That's it? Okay. Cool. I'm just surprised it's exact, that's all. But that's good. Okay. You don't have your calculator set around 2 decimal places or anything, right?
No, it is.
Hey, look, it's orange and,
Oh my, what's
Is
that?
It's like Slender
I don't know, is that like leopard or ocelot?
Slender Man. But red.
That's red, yeah.
I'm really freaked
Oh, it's STI.
I know.
No.
Everyone pick up our
Not this
t-shirt. Ah.
Oh, we're in.
How dare you?
No, sorry, drawing a blank. What's her name? Yeah. So still though, I wonder what is it? Ocelot? Is it not? Or it doesn't matter, right?
It's a Cheeto.
It's a cheetah in camo. And it says Morpheus on your butt.
This is all being recorded.
I know it is too. Okay, this visit was brought to you by. Okay, so what do we want? So we want 2s4 minus 10, which is?
50.66 times 10.
Which is?
40.66.
Units?
Meters.
Meters. Don't forget units, right? Or I forget half marks. Oh, I forgot to give you a half mark there. No, I didn't. I took a half mark away. With a smile on my face. Huh, no units, no marks. So put units on. Here's when you don't need units, although if it says the distance the ball traveled when it hits the floor for the 4th time to the nearest 100th of a meter is, then you don't need units because we already put the units in the stem. However, it's better just to always put units so you're not worried about the, hey, did they put units in the stem so I don't need to write the units? Or, you know, I'm just always going to write the units. Okay, this is a common type of problem. Bouncing balls, pounding a post into a post hole, or it goes down a certain distance each time, and stuff like that. Okay, running a relay race, right? So you run out 10 meters, back 10 meters, out 7 meters, back 7, and so on, right? Suicides, exactly. What's that? Is that it?
Yes.
Oh,
There's no more.
there's no more.
There's no